Welcome to section 14.1, Reflections, Translations, and Rotations. Remember to pause the video often, complete all the examples with me, and then you try problems on your own. In this section, we're going to be talking about transformations. So we have seen symmetry in designs all around us, and we'll cover symmetry a little bit more in the next section. But in order to study symmetry next, we first have to examine certain transformations of the plane. So reflections, translations, rotations, and glide reflections. Then in the next section, we're going to actually use those to define what we mean by symmetry, as well as create symmetrical designs. And then later, we're going to be studying congruence. So we're going to start this section out with an exploration. Remember not to skip these, even though they require supplies, they require time. It's really important to get your hands on the mathematics before we actually start doing anything. So in this exploration, I'm going to suggest that you use thin paper in a window. They use the language of transparency and graph paper. Graph paper, you can get some free resources by Googling or looking in the syllabus. When you complete this, go on to the next slide or press play. So roughly speaking, when we talk about a transformation, it's just an action that changes or transforms the locations of the points in the plane. So it takes each point and it moves it to another point. And that other point could be the same. You can transform it back to itself. And the three kinds of transformations that we're going to be talking about are reflections, translations, and rotations, and then briefly glide reflections. And always we're working in that coordinate plane. So let's get started with reflections and lines of reflection. So reflections, or a flip, they go across a chosen line, and we call that line the line of reflection. So for any point Q in the plane, so here's our point Q. For any point Q, imagine a line that passes through Q and is perpendicular to the line of reflection. So here's our line of reflection. And so here is our perpendicular line. See how it makes a right angle? So it's perpendicular to that line of reflection, and then the point Q moves the same distance. So whatever this distance is from the line of reflection, it moves that same distance to the image of Q, or Q prime. That's what that little apostrophe means. The end result will be a reflection. One way to think about reflections is that each point in the plane goes to its mirror image on the other side of the line of reflection. So we've got Q, here's our Q, and that's going to go to Q prime, which is our image of Q. An informal way to see the effect of a reflection is to draw points or a shape on paper in wet ink or paint, and then quickly fold the paper along the desired line of reflection. And then the location where the wet ink rubs off onto the paper shows the image of the point or shape after reflecting. That's a great exercise to do with your students. So another way to see the effect of reflection is by drawing points or planes on a transparency or a thin paper and going to the window, and then flipping that transparency or that window image upside down by twirling it around the desired line of reflection. Let's do an example here. So on graph paper, draw X and Y axis, which we have, and draw two shapes that are not symmetrical. Okay, so let's say I'll draw this rectangle here, and I'll draw this triangle here. All right, and then draw the result of reflecting the shapes across the x-axis. Okay, so here's the x-axis. This is my line of reflection. Now remember, from each point, we're going to take a perpendicular line to this, so a perpendicular line to this point, and we're going to move it the same distance. So this is 1, 2, 3. So this is going to be 1, 2, 3. This is a perpendicular line, 1, 2, 3, 1, 2, 3. And then here we're going to move 1, 2, 3, 4, 5, 6. Now 1, 2, 3 more, 3 more, and then there is my reflection over the x-axis. Here's another way to kind of think about it. So we've got we're going to reflect this. It's going to go 1, 2, 3, 1, 2, 3. And then if I don't want to do every point, I can just rebuild that shape. This point is 1, 2, 3 away from that, 1, 2, 3 away from that. And this point is 1, 2 up and over, 1, 2 up and over. So there's two different ways to build those shapes. So these are our reflections. On the graph paper, draw X and Y axis and plot the following points, labeling them A, B, C, D. Okay, so we've got 3, 4 is A, -5, 2 is B, -4, -5 is C, and 3, -4 is D. Plot the location of these points after they have been reflected across the y-axis and label the images of their primes. So we've got across the y, so this is 1, 2, 3, 1, 2, 3, A prime. This is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, B prime. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. If AB is a point in the coordinate plane, what will its location be after it's reflected across the y-axis? So now they want us to look at the coordinate points. So now let's label those. This was 3, 4. This was, and we'll see if we can find a pattern. C was -4, -5, and D was 3, -4. Now this point here is 5, 2. This point here is -3, 4. This point here is -3, -4. And this point here is 4, -5. So what do we notice? Well, I can see that the y value is going to stay the same. So if it was AB, the reflection, I know that the y value, remember this is xy, is going to stay the same, right? -5, -5. What changes with the x value? It changes sign. If it was positive, it becomes negative. If it was negative, it becomes positive. So if it was A, it becomes -A over -AB. Go ahead and give this problem a try. Press play when you're ready to see the solution. And here's just some example of the shapes and how that would change. So now we're going to talk about translations, and we're going to start by talking about vectors. And so who better than vector to explain vectors?
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!
Okay, so the idea is that a vector is an arrow that has direction, right? At the end of the arrow, it tells you which way, and the magnitude or length or value. So what a translation does, or you could call it a slide, but the official name is translation, we're going to translate something by a given distance in a given direction. There's our vector. The length and direction is the end result of moving each point in that plane according to that distance and direction. So taking a look here, if this is our arrow, this is our vector, it's telling us the distance and direction. So it's saying, okay, if we start with U, we want to move it this far. And so that's what all of these images have moved point T to T prime, point S to S prime, according to that distance and direction. Let's do an example here. Construct the translation of the triangle ABC using translation vector V. So the thing is we need to know how far to go, and it's kind of hard to do this slope here, but we'll just make a triangle. Let's see how it goes. We want to go down 1, 2, 3, 4. So we want to go down 4. And we want to go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. And we want to go 9 to the right. And that's exactly what we're going to take each point. So let's start with C. We're going to go down 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, again, you could do that with every point, or you could rebuild. I'll do here, this point B is going to be 1, 2, 3, 4, 5 above. 1, 2, 3, 4, 5 above. 1, 2, 3, 4, 5 above. This should be C prime, B prime. But I'll translate A so we can have another practice of it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that's going to be A prime. And again, it should be aligned 1, 2, 3, 1, 2, 3 away. And that's translating according to a vector. Go ahead and give this one a try. Press play when you're ready to see the solution. And we'll come back and continue with this section.